Hi everyone, let's see the final lab protocol. In the first part, we determined the cloud points of three different lipids: olive oil, coconut oil, and clarified butter. We have three samples. First, we heat our samples in a warm water until they are completely melted. Then we transfer them into a cold water ice bath to begin cooling. We insert a thermometer and wait until we see the cloudy look. Here it starts. So the sample should be no longer visible when viewed horizontally through bottle and sample. So the cloud point is the temperature at which the oil begins to cloud, resulting from crystallization under controlled cooling. So we are talking about here crystallization. So remember crystallization, the first step is nucleation. So here nucleation starts. So during nucleation, first small crystals are formed. Then they reach a critical nuclei size. And at this critical size, they can overcome the activation energy needed to grow into bigger crystals. And during crystallization, three acylglycerols can pack in different forms depending on the lipid type. So cloud point is the temperature at which crystallization starts. Therefore, the cloud point is related to the packing of three acylglycerols within lipid crystals. And packing relates to, remember, chain length. And also chain type. So when we say type, it's like straight or band. So when we compare the cloud points of these three lipid samples, we need to consider their chain length and type. So cloud points will be higher for three acylglycerols with longer chain length and three acylglycerols with straight chain fatty acids. And remember, saturated fatty acids have straight chains. So it will also depend on the degree of unsaturation of the oil. So in general, the higher the unsaturation of an oil, the lower will be its cloud point. So unsaturation, cloud point will be higher. So it's lower. Okay, the higher the unsaturation of an oil, the lower will be its cloud point. So in your lab report, discuss these points and mention about what are the major three acylglycerols found in those lipid samples. What are the major three acylglycerols? You can search in Google and relate your discussion to that three acylglycerol composition. What are the chain lengths? What are the names? Is majority of that three acylglycerols have saturated or unsaturated fatty acids? Something like that. So briefly discuss them in your lab report. Let's continue. In the second part, we determine the saponification values of the lipid samples. For this purpose, these samples are reacted with a base, potassium hydroxide. They are reacted in a condenser and reflects for 1 hour. then titrated with an acid to faint pink endpoints to neutralize the solution. And the saponification values are calculated by using the given information and volumes of titrants. But you don't need to do the calculations, I already did. You can find them in the data file. So in your assignment, you need to explain the differences in the saponification value of those selected lipids. They all have different saponification values. So why? This saponification value is defined as the number of milligrams of potassium hydroxide required to saponify completely 1 gram of the lipid. It's a measure of the free and combined fatty acids present. Basically, fatty acids are neutralized with a base and then you obtain soap. So this saponification value is a measure of the free and combined fatty acids, but since these oils are refined, in our case it's a measure of the combined fatty acids present in the 3-acylglycerols. So generally, the molecular weight of the lipid can be calculated from the saponification value. Saponification value is related to the average molecular weight of all the fatty acids present in the sample. So the higher the saponification value, the lower the fatty acids average chain length, fatty acids, and the lighter the average molecular weight of 3-acylglycerols. Okay, by obtaining saponification value, we have an idea about the average molecular weight of our lipids. Okay, let's continue. So in this part, we are making tofu. Tofu is also known as soy curd. It's generally obtained by coagulating soy milk. And we start with soaked soybeans, therefore we need to first extract soy milk from soaked soybeans as described in the protocol. So first step is the extraction of soy milk from soybeans. Okay. Then selected salts, which are calcium chloride, magnesium sulfate or ammonium sulfate, are added to the heated soy milk. And after 20 minutes, the liquid is drained. And you end up with soy milk curd. The soy curds are then processed into tofu in a desired form, primarily like in custard-like blocks. A variety of textures may be produced depending on the water content. Tofu comes in soft, firm, and extra firm forms. So what's the mechanism here? So we said we are coagulating milk, soy milk. So we have a coagulating agent here. Our coagulating agent is salt. We are using different salts here. 1 gram of salt, 1 gram of water, 1 gram of sodium, 1 gram of potassium, 1 gram of potassium, 1 gram of sodium, 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 1 gram of potassium, 1 gram of sodi So salt change the electrostatic interactions and curdle the milk, coagulate the milk. So you need to explain this mechanism here. Describe the protein functionality in tofu making, how protein form a gel network with addition of salt. So when we add salt, this salt out the proteins. So you need to describe the salting out mechanism here. Remember, there are salting in and salting out of proteins. We talked about in the lecture. So here, that salt concentration is high, so there is a salting out mechanism. Okay, then calculate and compare the tofu yields, because salt type also affects the salting out of proteins, and therefore you will have different tofu yields. Okay, explain them in your assignment. Let's see the last part. So in the last part, we bake angel food cakes by using 3 different recipes. And in your assignment, you need to compare the cake heights of these different recipes. Angel food cake structure is based on egg white foams. So there are no other leavening agents besides the air bit into an egg white foam during mixing. So what are the differences in those recipes? So this is the first one. In the second one, we increase the sugar. We have more sugar here. What about the third recipe? Here, in addition, we have butter. Okay? That's the difference. So these recipes result in different cake heights. Here we need to compare the foam performance of egg whites. So this cake heights relates to the foam performance of egg whites. Here we have an illustration. Here we have a raw egg whites with 10% protein. Egg whites are great for making foams. To make a foam, you need to whip egg whites with a beater or wire whisk. The whipping action denatures, unfolds the proteins. So there's a protein denaturation here. So denaturing the proteins exposes hydrophilic, water-loving, and hydrophobic, water-fearing parts. The hydrophobic parts of proteins orient themselves around the incorporated air. So this forms a protective lining around the air bubbles, so they don't pop. So depending on how long the egg whites are beaten, a foam can be classified as soft, firm, or stiff. So what factors affect that foam formation, the foam performance? So in the second recipe, we have more sugar. Okay? Sugar increases the viscosity of the solution. So sugar thickens the egg white mixture. This increases the time it takes to form because the mixture doesn't spread into thin walls around the bubbles easily. But sugar does add stability to the foam. So sugar improves the stability but decreases the foam volume. Again, decrease in foam volume is due to the increase in protein stability. That's why in this type of desserts, sugar is usually added after foam formation. So sugar adds the protein stability, but decreases the volume of the foams. And in the third recipe, we have butter. So lipids are more surface active than proteins, and they adsorb to the air-water interface. Therefore, butter has inhibiting effect on foam formation, egg white foam. So it decreases the foam capacity. Okay, that's all. Let me know if you have any questions.